Okay, we're coming to the conclusion of 10-2 arithmetic sequences and series, and we're being asked to determine the series of an arithmetic sequence using sigma notation. And what we have here, we got our sigma notation, and we got some terms above it, below it, and beside it. Let's talk about what these are. Well, this m equals 9 is going to be the first number that we substitute in here for n, and we're going to use it to find a1. And then we've got 21 up here, and 21 is the factor that we're going to use. We're going to use this to determine a1. We're going to use this to determine an, or the last number that we have in our sequence. And this 5 right here is actually the common difference. So let's start off and calculate this by hand. And once we do one by hand, where we kind of get a sense of what's going on, we'll do one by the calculator. And might I say, it is much easier that way. So first, let's find out what A1 is. So A1 is equal to 5 times 9 plus 6. So A1 is equal to 5 times 9 is 45 plus 6. So A1 is equal to 51. How about let's figure the last number that we know in the sequence. This is going to be AN. So AN is 5. We'll substitute in 21 for M. 21 plus 6. And AN is equal to 5 times 21 is 105 plus 6. Whoop. Plus 6. And AN is equal to 111. So now that we've got AN and A1, and we also know the common difference, this 5 right here, let's go in here and let's find out how many terms are actually in this sequence. Find out a value for n. So you may remember if we go AN equals A1 plus n minus 1 times d. So let's substitute in. AN is 111 equals 51 plus n minus 1 times 5, our common difference. And 111 equals 51 plus 5n minus 5. And so then 111 equals 46 plus 5n. And let's subtract 46 from both sides. So 111 less 46 is 65 equals 5n. And we're going to divide both sides by 5, where n is equal to 13. 65 divided by 5 equals to 13. All right, now we're ready. We've got everything we need to determine the sum of this arithmetic sequence. We've got, we know A1, we know AN, we know 13, and we can plug this into our partial sum of the arithmetic series formula, which is Sn, that's the sum, equals n times A1 plus AN over 2, close parentheses. Let's substitute and plug in chug. Should have put an n probably there instead of 13, but the 13 represents the n. So we got 13 times 51 plus 111 over 2. And the sum of the series is now 13 times, let's see, 51 and 111 is 162, I believe it is, 162 over 2. Sn is now equal to 13 162 divided by 2 is 81. And finish it off. The sum of this series, Sn, is equal to 13 times 81. Get the calculator out, multiply those two together, and it's going to come to 1,053. Okay, Shazam. The sum of the series using sigma notation is 1,053 in the case that we have presented before us. How lovely. Okay, so here we got we got another sigma notation that we're going to use to find the arithmetic series of a sequence. And I'm actually going to perform it on the next slide because we're going to use a calculator to do it, and it takes up the whole screen, so okay, whatever. So this is coming from page 670. This is in the what we would normally assign as homework assignments, and this is actually problem 13 on page 670. Let's just kind of go over what we got here, and then we'll jump to the next slide. So we got this sigma notation, and below it we got x equals 1. This is what we're going to use to find A1. We're going to use that. And we got 12. We would use it to find what is AN. This 3 here is our common difference, and we can use those things to find N, just like we did if we were doing it by hand. Find N and then plug it into the partial sum formula, and we can determine the sum of the sequence. And as you noted from the last slide, it took just a little bit of time to do so, but we're going to use our calculators. It's going to be a whole lot easier. And so we might want to jot down this sigma notation so that we have the figures before us as we move forward to the calculator. Okay, are we ready? Now, if you recall, we had a sigma notation. So we got our big sigma symbol, and below it was k equals 1 or x equals 1. K is just a variable. And on the calculator, I'd rather use x than I had k. I could use k, actually, but I don't want to. I'd rather use x. So we're going to say x is equal to 1 rather than k is equal to 1. Again, this is coming from 670, page 670, problem 13. And above the sigma, we had a 12. And then for our function formula, it was 3k. We're going to use x. 3x plus 9. So let's do this on the calculator rather than by hand. I'm going to hit right here. See the little alpha button. I'm going to hit alpha window. Now, it doesn't show up real well, but right there in option number 2, that is actually a sigma symbol with the parentheses, and I'm going to select option 2. And Shazam, look what pops up. So now all I got to do is fill this in. I'm going to say x is equal to 1. Got the bottom part of the sigma finished. I'm going to hit my up arrow, and above it we had 12. I'm going to substitute 12 in the little block there. I'm going to hit the right arrow, and I'm going to fill in here 3x plus 9. And I'm going to take my cursor and I'm going to move it past that parentheses to let it know I have put everything I intend to put in there. So I've got sigma, above it 12, below it x equals 1. I'm substituting x for k. And then in my formula, I've got 3x plus 9. I'm going to hit enter. And Shazam, the sum of that series that has first number, let's see, would be 3 times 1 is 3. Plus 9 is 12. First number in that series would be 12. Oh, did I say 12? Yeah, 12. And the second number would be whatever. Well, 12 times 3 is 36, plus 9 is 45. Second number would be 45, or AN, excuse me, would be 45. And the sum of that sequence would be 342. I think you might agree that it's much easier to use on a calculator. Alpha, window, select 2, fill in the boxes, hit enter, and you are done.